Hello YouTube, my name is Lenny, and I have designed a 3D printed shock absorber, and I want to show you it. I can go over the design process in another video. I previously recorded it explaining it, and I didn't have my audio on. I was trying to figure out how to get my headset to work. Yeah, that's nice. Well, it was practice. So, this is what it looks like. There's a selection view that splits it in half, and I can move it up and down. So it looks like. There'll be fluid in here. I'm using castor oil. I used olive oil, but it was seeping through the layers. Even when I had it upside down like this, it was just seeping through the layers somehow. So I thought, since castor oil is thicker than olive oil, it would be harder to seep through the layers. And I watched a video educating me on making prints waterproof, these submarine guys in Europe, and I'll post it in the link. They helped me out. So I just slowed down my print, and yeah, I just slowed down my print and did smaller layer lines to make sure they adhere correctly. And I think there's none leaking out. Yeah, there's none. Awesome. Yeah, I have it with me right here. So, I'll just quickly explain it. Actually, you can see it here. So, there's these little divots for the hard stop. The black ones are TPU. This is the hard stop, and this is the seal. There's little divots to hold it in place. I just push them in there. When I print it, I basically cut it in half, like the way it is now, and then I push both halves in. If it was a solid cylinder shape, I couldn't fit it around the piston, because the head's here and this is here. So I do this, and it actually works out. And then this base, it's kind of self-explanatory, I feel like. There's a slot, so I just slide the piston in, and then it's sitting in the middle. And then the spring basically holds it in place. It guides it in place. Yeah, sorry, I forgot to mention there's no spring here. But holds it in place. And then these guys are my ball joints. These are the ball joints. Oh, yeah, these are the ball joints. They rotate. They're printed in place. I just added about let me see. So the difference here. 0.4 millimeters for diameter, 0.2 on each side, 0.2 millimeters on each side for tolerance, and it seems to work out well. And I made sure they were flat so I can print them flat. Okay, the big thing I had trouble with was the spring, and I had to ask ChatGPT to try and figure out how to calculate the strength of it. So this guy is really strong, actually, because he has very little loops. And I was like, I thought if you had less loops, your spring would be weaker, but apparently it makes it stronger. If you have less loops, stronger spring constant. Because if you divide by a smaller number, you in turn get a bigger number. So this formula, spring constant, is essentially the constant that relates how much you compress your spring to a force. So this increases if my material strength increases. It increases if my coil diameter increases. So the thickness of the coil itself, the profile. This is an ellipse. There's a way to get an average of the diameter, which if you care, it is the width multiplied by the height of your ellipse, and you take the square root. So it essentially gives an estimate of an average diameter if that was a circle. It's not as complicated. It's more of an estimate. And then here is the diameter of your coil itself. So if you look from a top-down view, this mean diameter, this circle running through the middle of your spring. If that increases, the strength decreases, and the number of loops, as mentioned before. Now, I'm not a scientist. I'm just a high school student. So I think that as your loops decrease, it correlates to the pitch. So if I have more loops, this thing's gonna be tightly wound. And if I look at this guy here, see how he's, I would say, a 30-degree angle. See what I mean from the horizontal? 30 degrees. If you have more loops, they get closer and closer to horizontal because they have to fit that many loops in there. And if you've ever tried, if you took a stick and put it on your desk, or like if you took a big wooden beam, put it in the ground at 45 degrees. If you push on the top of it, it's gonna fall. Okay, but now if it's like standing 60 degrees tall, more like, instead of being like this, it's more like this, and you push down on top of it, it's be harder to push until you're almost vertical, and you basically can't push it over by pushing on the top of it. I think with that principle, because if you have less loops, they get closer to vertical because they have to occupy the same height in less loops. So it relates to your pitch, which is the distance between the coils. This is your pitch right here. So because of that, and as well as the radius increasing, or the diameter of your coil increasing, if it was bigger, they'd have to travel more horizontally. If they travel more horizontally, it's easier to push down. That's my layman's understanding of it. But please let me know what you think. I would like to be learned if you have any comments, and I'll show you what it looks like. Okay, I'm back. So this is what it looks like in real life. Alright, I have it upside down just because I don't want the oil to fall out. I think it would just make it harder, make it easier to fall out. So I have it upside down, but it still works the same. And I don't have the ball joints on. Those are printing right now, and then I gotta glue them on. But this guy kind of works. I'm pretty sure it works. The spring's pretty good. It feels similar to my real one from my RC car. And it just feels harder because I think there's a better seal for the oil. It's hard to do. Like I don't know if they vacuum seal it. It makes sense, but mine is like rubber just blocking the oil from spilling out completely. I'm happy with it. So that's what it looks like. Top, bottom view, top view. Yeah. And here's the really strong spring. So these are, I'll show you the difference between the two. This is the really strong one. Like this is hard to squeeze. This is really hard to squeeze. You'd have to make your own to feel it, but like this is like, it's like light work. You know those grip tests? This one's like the killer 150-pound gorilla, and this one's like the twig. Yeah, that's. I hope I made your day. Maybe you like this. I don't know. Thanks for watching.